Okay. Chapter 4. We are factoring quadratic expressions. Whenever I say factoring, what this means, this is, for example, I give you the number 10. What are all the factors of 10? So when I do my factors, I mean the numbers that would be multiplied them together will give you the number 10. What are they? 5 times 2, 1 times 10, or 10 times 1. Does it matter the order? No. So factoring means we are rewriting the expression as a product of factors. 2 times 5 is going to be a product of factors. Now, a monomial. What does mono mean? 1 means mono. What does bi mean? 2. And what does tri mean? 3. And what does poly mean? Many. Ooh, I like it. Okay? A monomial is a number or the product of a number or variables. For example, 6 is a number. X is a letter. It's a variable. By themselves, it's a monomial. I can have the product of those, 6x, y, z. That's totally legit. You understand that. That's silly monomial. A binomial is whenever you take 2 monomials and attach them together by additional subtraction. For example, 6 plus a. 7b minus 8xyz. Okay, what would be a trinomial? 3 of them, like x squared minus 2x plus 1. Right? Good. Now, your textbook assumes that you guys remember this from algebra 1. Boiled peppers. Speed it along.
You told him he's not allowed to talk unless he raises his hand. So technically he can raise his hand and talk like this because you don't talk.
She's correct. but I'll obey the rules that you wanted.
Foil, first, outer, inner, last. The first terms are going to be the very first terms in each parenthesis. For example, my first terms would be, in this example, would be what? Oh?
X and 3x.
X and 3x would be your first terms. What's my outer terms?
2 and 4.
X and 4 would be my outer terms. What would be my inner terms?
2 and 3x.
2 and 3x. What would be my last terms? No.
4.
2 and 4. Do we understand that? Now, for those of you who have always hated foiling, it's very simple. Are you listening to me? It's the distributive property. That's all it is. If I cover up the 2 and I distribute the x into both of those terms, that's my first and outer. If I cover up the x and distribute the 2, that's my inner and last. Do we understand that? It's that simple. So let's do it, shall we? X times 3x gives me 3x squared. X times 4 gives me 4x. Inner, 2 times 3x gives me 6x. Bow. Last, 2 times 4 gives me
8.
8. Do I have any like terms here?
Yes.
Yes. Where are my like terms? It's my inner 2 terms right here to give me 3x squared plus 10x plus 8. That is the FOIL method. How many of you remember this from back in Algebra 1 and geometry? How many of you liked it then? Great. How many of you are still going to like it now? All of you. Good job. Okay. Now, wonderful thing about mathematics is we like to do things in forward and in reverse. Correct? So, this is the forward motion. Now we're going to go in reverse. So I'm going to give you this, and you have to give me the x plus 2 times the 3x plus 1, which is what we call factoring. Remember factoring? You guys have all done this before, too. How many of you like factoring? Yes! How many of you hated factoring? Yes! Okay, here's what's going to happen. We're going to learn it. We're going to like it. We're not going to get cocky. We're not going to get overconfident for those people who think they're really good at it. Because I am here to trip you up because it's fun for me. Okay? I love factoring. Factoring is extremely important for you to learn and be able to achieve it. You need to be able to manipulate it. You guys are master manipulators. Why? Because you're teenagers. Interesting. Okay? Now, who are those people who whenever you go swimming and the water's a little chilly that you just step in a little bit at a time? Get used to the water. Then you step a little bit further up to your waist. You get used to it again. Who are those people? Okay.
I just dive it.
I'm that person who dives right in and says, "Oh, it's cold," and then I'm like, "Yes, I'm used to it now. I'm good to go." Okay. Who are those people? See, we are those people we like. We're all in, right? We're all in, like Donkey Kong, right? All in.
That's right.
Now, that's what we're going to do with this. We are just going to jump right on in and we're going to do some problems. Awesome. Well, I kind of cheated on you. What we're going to do first is we're going to talk about one concept here.
We're all in.
We're all in. But before we can be all in, I got to make sure that your brains are still thinking.
And we ready for nothing.
You ready for nothing? Here's my question to you. I want 2 factors of 10. That will give me a positive 10 every time. 25? So you're telling me a positive 2 and a positive 5. A negative 2 and a negative 5. So what you're telling me is if the signs are the same, then the outcome is always positive. So to get a positive outcome, the signs are the same. Plus, plus, minus, minus. This is so important. Okay? This is so important. So obviously, if I ask for a positive outcome, what do you think when I ask for next? Okay, what is the negative outcome? How do I get a negative outcome? No?
Positive and negative.
When my signs are opposite, plus minus or minus plus. You understand that? So to get a negative outcome, your signs must be opposite. Do we understand that? Yes, ma'am, I do get it. Want me to how we go? You ready?
Let's write that down very good.
I agree with you.
You knew it, but did you actually do it? Anything to make me happy. Are you ready? Jump in. Dive in! And then you come to the water. So, step 1. What do we see up here? What is it actually called? A monomial or a trinomial? Our goal, are we listening to my words? Because they are mathematical words that your brain needs to interpret and make sure that you understand. When you are given a trinomial, your first gut instinct is to take it and break it down into the product of 2 binomials. What did I just say? I used a lot of math terms there. When you are given a trinomial, your goal is to take it and break it down, being the product of 2 binomials. 2 monomials attached by additional subtraction, right? So do you see in your head? Do you see 2 parentheses with 2 terms inside of it? Okay? If not, put the 2 sets of parentheses down.
First one has to be a
Zip it, we're not there.
because
Zip it, lock it, put in your pocket. Okay, you ready? Okay. Now, the first thing I want you to do is I want you to say to yourself, well, I need to split up that x squared. So how can I split up x squared easily? No. X squared is the same thing as x times x. Because what we're talking about today is nothing but factors, right? So what are my factors of x squared? X and x. So I need up, right? So I'm going to put x in the first 2 slots. The next thing we're going to look at is that last sign. That last sign is a positive, which means I need to have a positive outcome. So how do I get a positive outcome again?
positive, negative, or negative.
Positive, positive, or negative, negative. Now how, in the world, do I determine which one I want to use? Plus, plus, or minus, minus?
You have to go no.
You are going to look at your middle term, okay? We looked at our first term, we looked at our last sign, now we're going to look at our middle sign. Our middle sign is plus, which tells me I have to have a plus, plus. So I ignore the minus, minus, and I put a plus and a plus here for the signs inside the binomial. Agree? Now, when your signs are the same, what this means is you are going to add. When your signs are the same, this means you are going to add. Are my signs the same inside of these two sets of parentheses? They are the same, which means I'm going to add. But what am I going to add? Because you're saying I'm adding two numbers, what in the world is that? So I'm going to take my last term, which is 20. And I need to find factors of 20. What are all the factors of 20? 1 and 20, 2 and 10, 4 and 5. Now, didn't I just say that we were going to add the numbers together?
Yeah.
Well, I want to add the numbers together to equal what? 9. The last term that we've not looked at is going to be that 9x. So I need enough factors of 20 that are going to add to give me 9. Well, 1 and 20 does not give me 9. 2 and 10 does not give me 9. What gives me 9? 4 and 5. Do we see that? So I am simply going to type it, put in a 4 here, and put in a 5 here. How do I know I'm right? FOIL. How many people in here want to do first, outer, inner, last, and combine like terms every time? Y'all fall and hit your head if you really do that every time. So the easy shortcut way is to simply what? Do the inner and the outer terms. Inner gives you 4x, outer gives you 5x, and when you add those together, it gives you 9x. Is that what I wanted to get? Yes. Do we understand that? Let's do it again, shall we? What is this again? And what's our goal with the trinomial? I need to break it down into two binomials that are attached by multiplication. I want the two binomials attached by multiplication. So I'm going to immediately put two sets of parentheses up here. And I'm going to say I need to break down x squared. What are my factors of x squared? X and x. And I'm going to say I need to have a negative outcome. How do I get a negative outcome?
Positive,
My
negative.
signs have to be
Positive or negative or negative or positive.
positive or negative, negative, positive. What is that? It's a really easy word for that. Opposite or different. Do we understand that? Okay, so since we have opposite signs, what are we going to do? Well, if the same sign meant to add, opposite signs logically need to subtract. Does it matter which way you put these?
Yes.
Plus minus or minus plus? Does it matter? No, it doesn't matter. I'm always a plus minus girl because I'm positive or negative.
Yeah.
Okay? How many of you put negative plus on yours? I'm very glad. That means you're a negative, Nellie. Sorry. Okay. Now, I need to have a positive 14. Now, what does that mean? That means whenever I subtract these two numbers, I need to have what type of an outcome? A positive outcome, which means how do I get a positive outcome? Which number is going to get the positive sign? The greater or the larger number. Do we understand that? It goes right with the concept of subtracting way back in the day with integers. Okay? Now, I need factors of what? 72. So 1 and 72. What's next? 2 and 36. What's next? 3 and 24. What's next? 4 and 18. Can I stop?
No.
I could. Why can I stop?
But you need to know all that is cool.
Because what am I looking for?
4 and 18.
I'm looking for factors of 72 that will subtract to give me the middle number, which is a positive 14. You see that? As soon as you say, hey, did I come to it? Well, it sure isn't that, or that. I say to myself, what about 4 and 18? Can I subtract those to get 14?
Ding, ding, ding.
Yes, and I need to have a positive 14, so which one's going to be positive, which one's going to be negative?
4.
4 is going to be negative, the 18 is going to be positive, so I'm going to put the 18 here, and I'm going to put the 4 here. How do I know that I'm right?
Because 18 minus 4 is inner.
Inner gives you 18x, outer gives you minus 4x to give you the positive 14x. Do I know I'm right? Yay! Okay, look at this one. What's different?
The negative x squared.
Don't write that down. Give it time. Okay, now what looks different here?
The negative x squared.
The negative is in front of the x squared. Do you like it there? No. So if we don't like it there, what we need to do is change it. So how do we change it? We're talking about factors, right? So if we're talking about factors, can we do factoring out? And that means going fishing. Whenever I say go fishing, what does that mean we need to do? What do we want to pull out? The negative. We don't like the negative x squared, so we're going to factor that out. And if we pull out that negative 1 out of a negative x squared, what am I left with? X squared. If I pull out a negative out of positive 13x, what am I left with? Negative 13x. If I pull a negative out of negative 12, what am I left with? Positive 12. Now, it's odd. It's not right. Now, do I need to look at the original problem now?
No.
No longer. So what I need to do now is I need to put this into two binomials. So the first thing I'm going to do is I'm going to split up x squared. What's that going to be?
That negative still has to be there?
Yes, the negative still has to be there. That's saying just because you put your arm behind your back, that means we're going to cut it off so you can never have it back again. You have to keep the negative. It's part of the problem. That's why the arm is part of the
Yeah.
Okay, so how do I split up x squared? X and x. And I need to have a positive 12. That means I need to have a positive outcome. So how do I get a positive outcome? I didn't ask for the factors. Please answer the question I've asked. How do I get a positive outcome? Same sign. So I need to have plus plus or.
Negative.
So how do I know which one? Look at the middle sign, and the middle sign is negative. So which one do I use? Minus, minus. Are the signs the same or different? So am I adding or subtracting? They're the same, which means I'm going to add. Okay? So, now, we're going to add. So what are my factors of 12? 1 and 12, 2 and 6, 3 and 4. And I need factors of 12 that are going to give me what? 13 when you add. So what two factors are going to work? 1 and 12. Inner gives you negative x, outer gives you negative 12x to give you negative 13x.
Does it matter where you put them?
Nope, doesn't matter, because here's the idea. If I have 5 times 2, is that 10? Well, is 2 times 5 10? Did it matter that I swapped them? Nope. Okay. Do this one by yourself quickly, and then I'll pass out your homework.
So you just leave that negative there then? That's your answer?
Are you ready?
Yeah.
Okay, what's the first thing I do? Get rid of the negative, so that's t squared minus 7t minus 44. Then what do I do? Two binomials, right? So I'm going to have a t and a t. I need to have a negative. So what's that tell me about my outcomes? They're opposite. So if they're opposite, what operation am I doing? I'm going to subtract. Do we understand that? Okay, so now I need factors of what? I need factors of 44, so that's going to be 1 and 44, 2 and 22, 3 does not go, 4 and 11. I need factors of 44 that are going to subtract. It's going to be what? 7. So what is it? 5 and 4 and 11. So what goes where? 4 goes to the positive, 11 goes on the negative. Inner gives me 4t, outer gives me negative 11t to give me a lovely little negative 17.
Now, does that matter? If they're switching?
Now, the negative has to go with the 11
Why?
because it's the bigger number. The bigger number always gets the middle sign. This number right here, it's the negative, it goes to the bigger number. The bigger number is 11. Okay? Now, tonight's homework is this worksheet. Yes, there are 34 problems on it. No, you don't have to do all 34 problems. You have to do the evens for tonight's assignment. However, I'm a big believer in practice makes what? Perfect. So those of you who are overachievers and would like to do better on your homework and your assignments, if you do the entire worksheet, either all or nothing, folks, if you do the evens and the odds, I will make this assignment double, meaning if it's worth 2 points, you'll get 4 out of 2. If it was worth 5 points, you'll get 10 out of 5. You understand? Extra credit.
Now it makes me want to do them all.
Well, is it easy?
Some of them.
Okay, I'm going to tell you what's coming down the lovely little hill here is going to be some nice, harder problems. So should you relish in the easy ones for now? Should you probably take this and run with it? Oh, I would.
I say maybe one.
I'm an all or nothing kind of a girl. So you either do all the worksheet or you only do half the worksheet. That's the only way you're going to get extra. I strongly suggest doing this on a separate sheet of paper. Also, what do I want you to do? Check your inner and outer to make sure that it works. Any questions over what I just said?
Yes.
Yay, you have time to work on it the rest of the period. Get busy.